Oh, hey there. If you remember, I told you about making a PIR sensor that will help me turn off or turn on something whenever there is a motion. Yes, I'm up to it again. Now, I'll tell you a little story. Well, I went to the market to get LED strip for my project. I saw this lovely, nice looking LED strip. I fell in love with it just at first sight. And I felt, well, I could use this in my project, which was supposed to be about 12 volt project. Unfortunately, I got home and realized that the adapter connected to the LED was just a controller. It doesn't actually work with 12 volts, it works with 220 volts. Sad, right? So I thought, well, it's not bad after all. I've been planning to make something like a nice project for my bathroom. So when I go to the bathroom, I really don't want to touch the switch. I just want the light to come on and turn off when I leave, when I do my business. So I think a good idea already that I started thinking of is to hook up the 220 volt LED in the bathroom. So whenever I walk and it senses my motion, it triggers and comes on. And when I leave the bathroom, it goes off. I think that would be a fun thing to do and I can't really wait to get started. Let's get to it. Yes, in as much as we're trying to have fun, I think it's important that I warn you that you need to take extreme caution when working with 220 volts. It is highly dangerous and it could cause fatal injuries or lasting injuries. So literally it could kill you. That means you need to take extreme caution while working with it. So I would advise you to get into this kind of project if you're not experienced at working with 220 volts or electricity from the mains. At the same time, if you're experienced, you still need to take extreme caution and just be safe. Let's get to it. For this project, I will need some basic components. For example, I will need an old charger. You could, if you have a 220 volts to 5 volt converter, it's fine, but I think an old charger is enough for me. I will also need my PIR sensor. I have the PIR sensor. I will need a relay module. I will also need the connectors, and I will need this too, like the headers, similar to what you find on Arduinos. I would also need this, a little plug. You might have decided to use the 2 pins, but I think I find this around easily. So now that we have the basic components, what are we waiting for? Let's join them together. Now to start, I would like to put all the components together. So first I have this. From what you can see, you could see that at the USB ports, I've taken out the negative and I've taken out the positive. So at the same time, this is my live, this is the neutral. So I have joined 2 wires first before soldering here, then 2 wires before soldering, so you can see blue and another blue. So this tells me this is going to connect to the relay. This is going to connect to this header, and I've joined them together. So if I connect this, for the device that I want to trigger, we'll connect one neutral to this and the other to the relay. So I have one to this and one to the relay. So all that is left is the device that I want to trigger to connect to the other one. So the neutral will be connected, then the live will be joined by the relay. So that's just what is left. So I'll be putting this here. My relay would be here, and that's it. So what I will have to do is this 5 volts, I've joined 2 positive together, 2 negative together. So 1 positive would go to this PIR sensor, another positive will go to the relay. So 1 negative will go to the PIR sensor and another negative will go to this relay. So I will join them together now so you can see how it looks in the end. I would like to glue all the components first because they keep wobbling around while I work, so I'll be using the hot glue gun to stick them permanently to the board. Now that I've applied glue generously, so they're kind of permanently attached to the board, it is time to connect all the cables to where ground, trigger, then positive. So I'll change that now. And finally, the trigger and the middle. So all set and connected, it is time to test. So after hours of troubleshooting, I figured out that this annoying relay was bad and I'm stuck with the double relay even though I just need one. Well, it's time to change and let's wrap up this project. Just to show you what I'm talking about. You see, it's gone off because there's a motion sensed. And that's just a trick. All right, the circuit is pretty done, but I made a very interesting configuration so that anytime I'm connecting anything to this relay, since I've discarded the order block and I'm now using the double relay. I don't have any interest in the second relay. I'm only using this, but I can also use it for something, so it makes my circuits a lot smaller. So what I did is I connected the live wire to this and the neutral to this one. So what happens is this: once any other circuit, any other device I want to connect to this, I just connect it to common and common. I just want to know that I'm connecting to the two commons. Why? Because I know that this is going to be live and it's just going to be normally closed. So whenever I connect anything to it, this side is officially closed. There's current flowing through the live. However, I want to control this part. Although I have my neutral coming into the normally closed and it's there already, but it's not connected to this second part, the red one here. That's the neutral of this device. Now, to make it work, the relay does not work like the regular logic of Arduino or most programs. Now, normally closed, you should expect current to flow through when there is no trigger. It should be just officially normally closed. That when you get a signal, then it should open and disconnect. But that's not the case. As it's normally closed here and there is no signal, it is off. So when there's a signal, that is when the normally closed then work. So it's kind of the opposite way. You would expect when the voltage is below 2 that the normally closed should disconnect. But that's not how it works with relay. Relay normally closed means that it's just the opposite. It's normally closed. The circuit is not working at that time unless you get a high signal before it works. So now it's time to test what we've been doing, and I think this time I will have to move the camera around. I can't really touch anything because we're still looking at a bit of 220 volts. So it's connected, switched on, and here you go. You can see the LED. So now, by default, once you turn it on, it doesn't stabilize immediately. The PIR, like I said earlier, will still trigger until like 30 minutes or 30 seconds before it normalizes. So I'll let it go off, then I will go to bother it a bit.
So watch this as I walk past the motion sensor. So watch the way the LED will come on.
That was quick, right? Isn't this beautiful? Watch how it turns on. You see, that's the sensor over there, and illuminates this place. How awesome it is. Lovely.
It's time to put it in the case, and that is what we want to do. Let's get to it immediately. I can't wait to put all of them together. Really excited about this.
So I got this socket plastic, and what I did was to glue Velcro, use glue gun to glue Velcro, and I did the other side here, a little bit of measurement. I can just cover and I have it in place. So I've cut out the place. Well, if I still want to charge anything through the USB, I still have it. And if this is where the connector to the LED will come in through, I'll still file this so it looks a lot neater. What would also happen is over time I'm going to bring out, you know, the female of a plug. So it's just 2 points, and I'll connect the other points straight to the female. But because it's not a permanent circuit for now. So I have this sorted. I'm really concerned about it fitting in the box. Don't forget, come on. You can easily detach.
So I've managed to cramp everything inside. It is time to, clean up the wires and cover. So the last part is just to make sure I reduce the length of these wires. And after that, I tied this part so that when I close it, you can't really pull out, and so you don't pull out and affect the component inside. So those are just the basic changes I've made, and this is what it's going to look like. This will stick out. So the last finishing touches should start now. Yeah, for now I've just hooked up the LED for a temporal testing phase before something more, concrete. Now I will turn it on and let's see how long, because I increased the timer. Perhaps you should be able to stay on for about, let's say, 3 minutes before the trigger goes off. Alright, since it has gone off, I'm going to walk past the trigger it again, and that was after 2 minutes. And that's it. Thank you for watching. So I should use this opportunity to talk about the LED. It has some switches, so clicking on the switches you can regulate I think about 8 channels. So 8 what did I say? Functions, 8 functions. So that's pretty much like bright light. I used to like this because you could just change colors, and it's actually lovely though. I like it. And bright, really bright. You need to see this at night. This is one I eat the most. I like this too. Changes. Wow, this is my favorite. Oh, so lovely. Oh, and here you go, the little Bobby, my new best friend.